Hi guys, this is Krish here, Krish Naidu, and I am today I'm going to present the inventory optimization process in front of you. And it was a scheduled meeting which we have already posted on various social media groups like LinkedIn, Facebook, Twitter, Thread, Instagram. So we posted about this event uh, in the last 10 days before, and we were trying to tell people about this particular event. So today we are live here on this particular program. Um, so the idea, let me share about what we are. So we are a company called Mathnal Analytics, based out of India, and let me share you my website. That is mathnal.tech, which I'm typing over here. So I'm sharing my website here, which is mathnal.tech. We are a consulting and training company. The focus of our consulting services lies on the automation part, automation of the entire decision making process, which starts from which starts from the gathering inputs, then using ETL tools to clean and transform the data, then take the clean and transform data into the predictive analytics engine or maybe the machine learning engine. And at that particular process, we create insights using the predictive analytics and machine learning engine. And once we create the insights, once we get the insight using the machine learning and predictive analytics engine, then we do multiple supply chain decision making process. Like we do forecasting, we do inventory replenishment calculations. Then we also do the supply network optimization. Like in this, we do vehicle route optimization. We also we create cost optimization. We do lead time optimization. We do inventory optimization. So many things we perform. So we have generally a process. Let me share you the process which we are going to generally work on this case study. So the case study which we are going to discuss on this particular session is all about inventory optimization. So how this inventory optimization is where we are going to cover. So we are going to take some inputs from the ERP. So I will not be taking the example of ERP over here. I'll be directly taking the input, which is sample input, and I'm going to use the sample input to I will not even give you the example of how to work on the Power Query, because Power Query is an ETL tool. So there are various ETL tools in the market. So we are going to use Power Query as one of the ETL tools. So so there's some people want to join. Uh, Let me. They're facing some issues here. So let me help them again. Okay, so let's go come back to the point of discussion. So we were talking about the role of Power Query. The role of Power Query is very important when we are working with the machine learning and predictive analytics algorithm. The reason why we need Power Query, because the first reason is that we need to automate the data cleaning and transformation process. The first reason what we want is this. So if we are getting a data, the input is coming from the ERP. The input is coming from the ERP. So the input which is coming from the ERP, it may be processable. It may be processable or it may not be processable. Right? The input which is coming from the ERP may be processable or may not be processable, or maybe can be used for processing uh, the machine learning algorithms, or cannot be used for processing the machine learning algorithms. So what we need to is that we need to convert the input into a processable input for the machine learning and the predictive analytics algorithm. So we need to convert the input from ERP into in processable input for the predictive analytics engine. And the focus of using ETL tool is to automate most of our cleaning and transformation process of data over here. So the advantage what we get here is the advantage we get here is that we do not need to transform or process the input again and again for each and every time we upload the data to work on the predictive analytics and machine learning engine. So this particular effort saves a lot of time. And what happens is you can get your input, you can convert your input from ERP into the processable input for the engine of predictive analytics or machine learning, right? Just with the click of refresh, because this is a one-time effort. So if you do one-time effort, so every time you don't need to convert this particular ERP input into the predictive analytics input. So that's a one-time effort which we need to put in. So this saves a lot of time, and I think this is the most important point for supply chain professionals, because they need to have those they need to learn this particular tool very well, or if they don't learn this tool, they need to hire the consultants to create a particular conversion or the transformation for the data, so that they save a lot of time in and focus more on the insight generation or on the insight analysis, rather than working more on the transformation process. That is the most important thing which the supply chain professionals will get benefit from this particular Power Query tool. So this is what one of the most important thing which we need to take into consideration as supply chain professionals. So we need to work a lot and lot on the Okay, so I think this is what we need to. It's a very important part of the process which we need to think about and implementing supply chain. Uh, the the third part of the process is template generate automated patterns and forecasts. So generally, what happens is if you're working on machine learning algorithms, if you're working with the predictive analytics algorithms, it's very important that we generate the we generate the we generate the patterns or we understand the patterns. And when we try to understand the patterns, we need to understand the patterns in a most automated way, because in supply chain what happens is you work with n number of items, right? Your stock keeping units might be thousands of stock keeping units, or uh, might be in millions of stock keeping units. So so it's very important that you know we create we understand how to create patterns in a very dynamic way, using statistical models methods. And uh, and once we are able to capture the patterns, then we can actually understand what kind of algorithms we need to create. So that is what something uh, we need to think about when we are working with the models. So this is where we are going to use some kind of statistical computing formulas within Excel, or if you are working in the Python environment or some other environment, you can also use that particular environment to create those kind of dynamic formulas to understand what kind of patterns exist in the. So let's see. I think my one of the peoples are still struggling to access the. So let me help them. So the third part. So what we're talking about is creating the automated patterns using statistical formulas, or maybe the in Excel, or maybe in the Python. That is what we need to think about. What kind of formulas we need to create to understand the patterns, because you cannot create any algorithm, or you cannot create any machine learning algorithm, or predictive analytics algorithm, or forecasting algorithm, unless you have the understanding about the patterns, right? And once we create the patterns, and then we apply the forecasting models, and after applying the forecasting models, we generate the forecast. Those forecasts will be aggregated. Like if you want to aggregate by the SKU wise, if you want to aggregate by the SKU and warehouse wise, right? So here, suppose let's before that, I want to discuss about the patterns. What are the patterns we can talk about? Patterns could be like seasonality, or trend, right? So these are some of those, or cyclicality. So these are the patterns which we talk about. So if we have this kind of patterns, once we know the patterns, right, we have to create a forecasting algorithm. For example, if you have a trend pattern, right? If you have a trend pattern, we're going to use a forecasting model like linear regression, or double holds model. If you have the trend and seasonal pattern, if you have trend as well as seasonal pattern, then you're going to use so you're going to use the suppose trend as well as seasonality pattern is there, right? You're going to use holds winter model, or we can use time series decomposition, right? If you have no patterns, then you can use single exponential model, or you can use right moving average, weighted moving average. There are various formulas. I'm not giving the total visibility of all the formulas here. So I'm just giving you a visibility of few formulas which are general. So this is something like, so once we know the patterns, then I think we can actually understand that what kind of models we can apply. So so we need to have a clear understanding about what kind of patterns we have, and detection of those patterns. The detection of those patterns has to be done automatically. So the other thing is that detection of the patterns. So we have to detect the patterns, and those patterns have to be detected, using statistical or statistical or analytics algorithm formulas. And this can, we can do this formulas calculation both in Excel as well as Python. So the tool is not a constraint. You can do in any tool. Even Excel is a very capable tool. So, so only thing we need to learn how to use Excel. Suppose if you have a very big data size, Excel cannot handle the big data size. So what you have to do, you have to use various techniques, and those techniques you can use in ETL tool like Power Query. Right? Power Query is an Excel tool. Right? In this, we can use techniques like Power Query transformation, Power Query transformation. You can use Power Pivot transformation. So if you're working with a big data set, right, there are various techniques in Power Query, like if you want to load the data as a connection, or if you want to load the data as a table, or as a pivot chart, or as a pivot table. So various techniques are there within the Power Table when we appear in the pivot table or in the Power Query. The way you load the data also plays a major role in actually the speeding up the entire process of computing. So Power Query is a very essential tool in supply chain analytics, because when we work with a big data size. So when you work with big data size, the Power Query can help us in actually managing the speed of the processing. But if you don't use Power Query, Excel might not be enough to help you in computing your statistical algorithms or predictive analytics algorithm or machine learning algorithms. It might be very difficult for you. So Power Query is something a very helpful tool within the Excel, where you can actually work with a big data set in a very easy way. Instead of when you work with Excel, big data set Excel will mostly hang, but it takes some time to process and come to a stable state. But if you use Power Query, those kind of hindrances, those kind of hangs, those kind of stoppages, those kind of can be eliminated or can be reduced by using Power Query. Okay, so now we've spoken about that. We take the data from the ERP, right, as an input. We take it input into Power Query. We do cleaning and transformation process, and we do value addition there. And once we do the value addition, we try to generate an output which has to be processed in the predictive analytics or machine learning engine or template, right? From where we're going to generate our outcomes in the form of forecast or whatever is the, suppose we're talking about the inventory optimization. So from the inventory optimization perspective, we're going to generate our aggregate forecast from the forecasting template, right? So once we get the aggregate forecast, then we take this aggregate forecast as an input to the inventory replenishment engine. So if you look at this process, which we are seeing is this process is actually This process is actually the input process, input to output process. The process which you're talking about here is this is an input to output process. So every layer what we're seeing, every layer at this point is input to the next layer. So every layer is the data. This is our ERP input. This is going to the processing. So this ERP input is the input to the Power Query. Once we do the processing in the Power Query, this output of the Power Query is an input to the forecasting engine. Once we do the processing in the forecasting engine, the output from the forecasting engine is an input for the aggregate forecast. And once we do the aggregation of the forecast, is that aggregation of forecast is the input for the inventory replenishment engine, right? So I just try to bring a very simple view of uh, the data flow. But when we work with the systems, it's not as simple as that. Okay, this is a top level view, but within this particular each and every block, there are multiple layers of processes there. So those multiple layers of process will be connected with the next layer of process, next layer, and within that next layer also we will have multiple layers of activities happening. So those activities, if I list here, it will become very complicated. I'm not going to list all those activities. I'm going to give a very top level view how we are going to reach our inventory replenishment engine from the ERP. Let me write this ERP here. So that will be much better. Yeah. So this is ERP. So ERP, from ERP we dump the data in Excel that goes into the process Power Query. Then Power Query we take into data into the forecasting engine. From forecasting engine we take data, we create the aggregate forecast. From aggregate forecast we take that into the inventory replenishment engine. And at this particular point we get an output, and that output will be our how much is the reordering, from whom we have to order. So and the entire reordering system will be created here, right? So this is the last stop. Reordering system will be created here, and then the reordering system, what are the things we create? The reordering system is when to order, and this has to be done automated. We have to create formulas which just the automated calculation. When to order, right? How much to order, when to order, and how much to order, from whom to order, then the supplier. When to order, how much to order, and from whom to order, when to receive, when to receive, whether to receive everything at once, or at multiple intervals, right? So these are decisions we will be making in the, and everything has is automated. Means you don't need to look at the, you don't have to do anything. Just you will have a template. The template will do all the automatic calculations. Everything is automated. You don't have to worry about any kind of thing. So just, and this particular total engine which we are talking about, this particular total, it is an automated engine. This is a completely automated engine. You don't have to. This is a completely automated process. So every morning you have to come to the office, just upload your input and click on refresh. Once you do that, you get your outcome. That is rewarding system. Simply you have to come to the office, upload your new input from the ERP over here in the processing query. The moment you do the input here, see this. So what you do, you dump the data from ERP. You dump the data. ERP, you dump the data, new data. Okay, then upload the new data inside the folder or inside the Power Query, and just the third step is refresh. You have to click on the refresh up button in the within the Excel. So what will happen is you get your outcome, that your entire reordering decisions, which we talk about, reordering decisions, right? Everything will be out. So it's just a very simple process. This is completing like it will take only 2 to 5 maximum 2 to 5 minutes. The doing the entire calculations in 2 to 5 minutes every morning. Just 2 to 5 minutes, you get your output. This is the most important part of the supply chain analytics, because we want to create our decisions, not only accurate decisions, but we want to create very fast decisions. And when we create those fast decisions and accurate decisions, we want crisp decisions. Means we want to understand. We have to be very. We have, by looking at the information, right? We know what we have to do into to solve the problem, or to if this is equal to trend and this equal to seasonality, we're going to use triple exponentials method, or else let's blank. And we have used one if, two if, three if, and four if. I'm going to have four closing brackets, enter. So like this is no pattern, single exponential. We have trend and seasonality, triple exponential. We have only seasonality, moving average. We only have trend, double exponential, right? So now we understood what kind of algorithm, what kind of forecasting algorithm we need to use, right? So based upon that, now we are going to work on, we are going to use our forecast. Forecast for how many periods? Let's say I'm going to use the forecast for the simple case, 6 periods or 6 periods. We can use the forecast for multiple periods, and this is called replicative forecast. We are not going to create, our approach to create a future forecast is different than generally. So we are going to use first create a replicative forecast. So let's say the replicative forecast over here is, so if this is equal to, let me also define here our alpha, beta, and gamma. So we have defined our three smoothing constants that we call as alpha, beta, and gamma. I'm going to use a random generator. So generally what happens if you have the trend component and you have weak season component, so the beta will be very high. If you have a strong season component and weak trend component, the gamma will be high. And if your season component and trend component both are less, then the alpha will be very high. So how this works is, if no patterns, then chances that alpha is very high. If there is a trend pattern, right, then alpha will be medium. Alpha could be medium. Chances that alpha could be having a medium value, and beta could be higher value. These are all possibilities. And if there is seasonality, trend, and if there is pure seasonality, of course we are not actually considering here, but if you use the model, same models, then the gamma will be very high. You can also use the same tier triple exponential model, but we are not using triple exponential model for seasonality only. So gamma will be very high. But if you have trend and seasonality, then alpha could be less, gamma could be medium, but it also depends upon the correlation factor, right? Gamma, beta could be depending upon the correlation factor. If the correlation is high, then beta is high, and the correlation is low, beta will be lesser, right? So like this, it were, this alpha, beta, and gamma works. Generally, we can create a grid of alpha, beta, and gamma grid with various kind of simulations, and that grid will integrate with the formulas, and we can actually get the best alpha and beta and gamma, which generates the lowest error. That's how we can generate. We can optimize the alpha, beta, and gamma in a big models. Now, if you want to actually Power Query is an ETL tool. There are various ETL tools in the market. Power Query is an ETL tool. There are various ETL tools in the market. Hello, hello. I'm audible, guys, because I'm just checking my voice settings here. Power Query is an ETL tool. There are various ETL tools in the market. Hello, hello. I'm audible, guys, because I'm just checking my voice. Okay, so let's go come back to the calculations. So now what I was talking about is that we need to have a grid. So where we have multiple alphas, and for those multiple alphas, will combine with the multiple betas, and with that multiple betas will combine with the multiple gammas, and those combinations will be going into the forecasting algorithm, and finally we'll choose the combination, the alpha, beta, and gamma, which generates a least error, right? So how we do this? We have to create a grid, random grid of multiple values of alpha, beta, and gamma, right? So so there's a suppose we have 10 values, 10 values of alpha, right? So the 10 values alpha will combine with, you know each will like it will be almost 10 into 10 into 10 into 10, almost 1000 combinations, or we'll say 1000 iterations for each forecast period, right? So for each forecast period, there will be 1000 iterations. So suppose if you are doing forecasting for 5 periods, it will be 5000 iterations. So it's a very heavy computing engine. If you create a random grid, or not random, fixed, but it's a grid. So fixed grid is a very heavy computing engine, right? So like this, I'm not creating a heavy computing engine. I'm creating something like random values at each level. And we will do a refresh approach to select the best alpha, beta, and gamma. That's how we are going to work with here. Okay, so let's work on the first formula. So what we are saying is that if this value, if this forecast is equal to SCS, right, we're going to use our alpha into the previous forecast. The previous forecast is simply we take the average of the data set, plus 1 minus alpha into, these are the forecasting formulas, into again, let's say I'm taking the current average. uh, Let me do one thing. I'll create one algorithm here. Let me say this is my first forecast is average. My first forecast is simply the average, and let's keep this as constant for all the SQs. Now let's, if this is equal to SES, right? I'm going to use an approach called alpha into the current sales or the previous sales, plus 1 minus alpha into the previous forecast. So, for example, let me so AA4 is our alpha. So what we have to do, we have to keep AA4 means AA is constant. So I'm going to put $1 sign before AA. And C3 we don't have to keep anything, so it will be keep on dragging. One again, I have to do 1 minus A4, one dollar sign here, and AD4 is the previous forecast. I don't have to do anything here, right? So now suppose this is all SCS forecast. I can create a forecast up to, okay. One more thing I have to do, Z4. So Z4 is going to be, Z is going to be constant. I'm going to put $1 sign here also. Now I can drag this formula. This is automated now for SCS, right? If it is SCS forecast, this is automated. Wherever we have SCS, it will be automated, and where is not SCS, it will not work, because see, it's TES, it is not, it is showing false. Now let's automate this for the next level. What if it is? What if this is equal to TES? Let's say, yeah, TES. One more thing, I'll make a one change here. So let's say beta, right? If beta, yeah, that's not a problem. It's not a problem. Let's do this. Okay, so now I'm going to calculate if this formula, let's say forecast dot ETS. Okay, I'm going to take the target date. The target date here is 2, and our next is the values. The values is this. So I have to freeze this. If you have to freeze this, means I have to keep this C3 dollar sign before C, dollar sign before V, and then we have to take the timeline. This is the timeline. I have to freeze this because this has to be constant. Then I have to say whether seasonality exists or not. Yes, seasonality exists, and close the bracket. Let's see where is the issue. Okay, so the first thing is target date. So I think we have to mention the target date here. A3. I think A3 is already there. Target date A3. So I have to freeze this 3 here. So I'll put dollar sign before 3, and then we have a dot here. So I remove dot here, put comma. So this formula is ready now, right? So now I drag this formula and drag this. Now see, now we have a formula for SCS, TES, DES, right? We have formula for each and every component. So let me also use one more thing here. Mm, hmm. So I'll just write here, if this is equal to MA, if this is equal to MA, I'll take the average of 3 periods. It's a moving average. Or else I'm going to use this formula. So, okay, so now I have a formula here. So now what we did, we automated our forecasting engine. I'm doing in a very simple way. I'm not giving the total visibility of the engine. I'm just trying to give one demo, a small example. Okay. For example, if you look at here, if I change this to, right now this forecast is how much? This is the forecast. I'm just doing a copy paste here just to show you how this is going to change. Right. So I'm going to also, I have to this, right now this data is random, not random, right? Okay. So let me take this thing. Okay, this is 39.24. Why it is changing? Because, okay, this is random. Okay, so what I'm going to do, let's keep this. Let me freeze this first cell, first area. Now let's see. This is 39.24. I'm taking this and pasting over here. Now what I'm going to do, I'm going to change this to MA. See, the forecast is changed now. 45, 25, 25. Why? Because now this MA which we have used here, that is using average of 3 periods, right? If I'm going to change to TES, now this is changed to 26, 27, 28, right? If I make again back to SCS, Now we get what we had earlier, 13.5, 49.7, 44. So whichever forecasting algorithm which we are choosing, our forecast is automatically is going to calculate based upon that particular forecasting algorithm. And this forecasting algorithm is decided based upon what kind of patterns we have. So I just gave you a small demo how our forecasting engine is going. But this forecasting engine is lot more. We have lot more variables in our template, lot more variables which takes into consideration because we need to have a higher accuracy. So we take lot more things into consideration before we process this level of information. Okay, so because we need to make a lot of descriptive analysis. We have to do a lot of intermittency. We have to check. Then we have to also check whether we need to how to handle the multiple SKUs when we have intermittency in the demand consumptions or demand or the sales. So we have to take a lot of things into consideration. Then we have to compute our do the optimization with the MAPE. So we have to do the optimization also. So our template do a lot of activities, but I just gave you an example how our template works. It's automated, right? So just if you change from SCS to MA, we get a new forecast. If you change from MA to DES, we get a new, let's say DES, not DS, let's say TES, right? We get a new level of forecast, not DTS to SCS, right? Actually, this is an SCS. So I'll go drag the funnel back. This is SCS. So we got SCS output over here, right? So this is our aggregated forecast, which is going to take inside our replenishment engine to compute our reordering parameters. This is all the factor which we are computing over here. This is our input for replenishment engine. Input for replenishment engine. So once we get this input for replenishment engine, then we have to work on our other parameters. So let's say this is my input replenishment engine. So what I'm going to do now, I'm going to calculate and I'm going to get some new inputs like lead time of supply. This all thing happens in the Power Query, right? We don't have to do all those things manually every time. This all calculations which we are talking about will happen in the Power Query. So we don't have to do anything over here. If you have a new supplier, a new supplier data will also go into Power Query automatically. We don't have to, manually enter anything inside the engines. Everything will happen automatically. So you just have to upload the data with a new supplier as an input, and that particular information will come inside the replenishment engine, and it will automatically calculate the. So right now I'm using a random data, but I'm not going to. I cannot expose my client's data over here. So I'm just using a random data. This is my lead time of supply. Just I'm going to take the same way. The standard deviation of lead time, let's say 2 comma 15. So now we have our lead time of supply and standard deviation of lead time. Similarly, now we are going to calculate the average forecast and the standard deviation of forecast, right? So what is the average forecast? The average forecast is for 6 periods, right? This is what we're going to calculate our standard deviation of the forecast. Right, I'm going to calculate the minimum inventory. The minimum inventory is what the average demand into the average lead time, the lead time. And we have to calculate, let me also change my here. So this is my 2 comma 10. I'm going to calculate my safety stock. The safety stock, I'll take the calculation as square root power of standard deviation of demand, comma 2 into the lead time of supply plus power of average demand, comma 2 into power of standard deviation of lead time, comma 2, close it, and this is our safety stock, right? What is maximum stock? The maximum stock is our minimum stock plus safety stock, right? Now let's say I have a in transit data, right? I have a in transit data. So we had did some previous orders. We did some previous orders earlier. So like this, we can work on various kind of combinations. Suppose my previous orders, for the next 6 weeks, this is my in transit data, right? And what is my initial inventory before initial inventory before the week number one? Let's say I have initial inventory of 3 units. So once I have the initial inventory before the week number one, I have to find my closing inventory at week number one, right? We have to find our closing inventories or the opening inventories for week number two and all. So let's say my opening inventory at, let's say, let's calculate the opening inventory. So one, two, three, four, five. So 5 periods. I'll say opening balance at every week. So I'm going to start with 2, 3, 4, and 5. So what is the opening inventory at week number 2, right? So let's say we had the on hand plus the in transit, right? Minus the in transit minus the forecast, right? One is the forecast. So this is our forecast. So this is our negative inventory, right? So let me now what happens is this is my, let me calculate over here everything. So this is my on hand 3 units, in transit is 9 units, 9 plus 3 12 units, and I am short of how much units? Minus 31.5 units. Okay, this, if this minus 31.5 is, this is a back order. This is a back order. So now what happens is, of course, we need to understand what is your reordering policy. That's now what happens is this particular inventory which we have here, this is the on hand. I mean, this is a back order. Now this back order is going as, now let's say, what is my in transit? The in transit. So this is my plus, this is coming as back order plus in transit minus the 30.9, 39.54. This is opening balance for week number 3, right? Similarly, now we go to the week number 4. This is opening. This is our opening balance. Now I have in transit here for the fourth period. This is this one minus, let me, okay. So on the fourth period, we this is my oh, sorry, I'm sorry guys. So this is my on hand plus this is my in transit. On the fourth period, we have in transit, and we have the consumption at the fourth period is 44. So this is my in hand, right? This is closing inventory, and this is opening inventory for fifth period. So this is my opening inventory plus in hand minus forecast for the fifth period forecast right? So this is my closing inventory on fifth period. Then we go to sixth period, which is the opening inventory is this one plus in transit is this one, and the forecast in the sixth period is this one. So this is how I'm calculating my opening balance. But if you look at all these values are negative, right? It means we have a back orders. This all the back order means this particular outcomes, negative outcomes is flowing towards the the multiple one period head, and this flowing to the next period head. It means there is we have an opportunity for reordering at each and every level, right? Because there is a negative inventory. If there is a negative inventory, means we have to do the reordering. Now, similarly, we can compute our 1, 2, 3, 4, 5, 6 right now. So this is called weeks of supply or days supply, whatever you can calculate. So we can calculate this also. So weeks of supply is that take your current inventory. So in the first case, we have on hand divided by the average inventory. What is the average inventory? What is the average inventory? The average inventory is this much. So we have only 0.02 for it. So like this. So I have to freeze this the bottom value, and I can drag this. If it is negative, means we don't have anything, right? So this is the week of supply. So how much right now we are in negative because negative means we are already stock out. We don't have any weeks of supply. If it's negative value means we don't have any weeks of supply. This opening balance, if you see negative, it means we don't have any supply. It means we are already stocked out, and stocked out by how many units, right? So now we have to decide how much I need to order. Before coming to this point, I'll take you another simple example, and then we'll come back here. And also we have to calculate when to order. So how much do we need to order? For that calculations, I will go and give one demo, and then we come back here. For example, I have a data like this where we have the continuous review policy, because there is no time gap here. What is the difference between continuous? Sorry, what is different between continuous? I'm sorry. What is different between continuous review policy or periodic review policy? Let's first discuss this. So this is a timeline for continuous review policy. In the continuous review policy, there is no time gap between consecutive periods. So if you have done a review yesterday, then we're going to do a review tomorrow also, right? Or if we want to do review multiple times in a day, right? Suppose I want to review my inventory in the morning. I want to review my inventory in the afternoon. I want to review my inventory in the evening before going to home, right? So we can do review multiple times in a day, or we can review our stock out levels or service levels or on time or service levels, stock out levels, overstock levels, right? By updating the latest transactional data Okay, we can review our stock levels, service levels, and our stock overstock levels by updating a latest transaction data. So, what are the latest transaction data? That is, first is your purchase orders, right? How much purchase order you are getting. Second is how much is in transit, how much you are going to receive, how much you are going to sell, how much is expired, how much is how much is leaked. So these are the transactional data which you're going to take inside into consideration, and then after take, considering all this, after considering all this, transactions, then you will come up, and we have to update these transactions inside the replenishment engine, right? This is all the inputs which we have to take into which we have to take inside the replenishment engine and compute our metrics. So if you do this kind of, if you take this inputs or transactional inputs multiple times in a day, or if you're not taking inputs multiple times in a day or day by day, right? Then this is called continuous review of your metrics, inventory metrics, right? But if you do not do this, if a review policy, like suppose you are doing, let me say periodic review. Suppose you're doing periodic review, what is timeline then? Suppose today is 0, and you're doing a review next after 4 days, then after 8 days, then after 12 days, right? So your review is happening after every 4 days. The review is happening after every 4 days. So so what is happening to your inventory for 4 days? You don't know, right? If I'm doing continuous review, I know what is the status today and what is in the status to. I want to know what is status tomorrow, right? My if so I will be able to know what is my inventory after by this evening or by tomorrow morning in the continuous review policy. But after in the case of periodic review, if I review every 4 days, I will not know what is my status tomorrow or day after tomorrow, right? I will be knowing my inventory status after 4 days. So what is my inventory after 4 days? That is what I am going to have the understanding of the inventory status or of metrics. So there is a pros and cons for both the system, right? So we have to do some kind of risk management if you are doing periodic review, right? In the case of periodic review, what we have to do is that our total lead time will be, so we have two lead time here. Let's say the supplier lead time. Supplier lead time is one concept and periodic review is another concept. Total lead time will be our, let's say my supply lead time is 12 days, for example, right? My supply lead time is 12 days. So what is my total lead time here? The total lead time is 4 plus 12, 16 days. 4 plus 12, 16 days. So my total lead time is not 12 days. My total lead time is 16 days because have to give a risk management. I have to cover the risk because I am not looking at my inventory for 4 days. If I'm not looking the inventory for 4 days, then I need to have the cover for those 4 days. So for that, if I have to cover those 4 days, I need to have an inventory for 16 days, not for 12 days.
So this is a difference between continuous review policy and periodic review policy. In the periodic review policy, the lead time will be the total. This is a lead time for periodic review policy, and the lead time for continuous review policy is 12 days, because we are doing review multiple times, either multiple times in a day, or we are doing reviewing every day. So we don't need to have any risk management for period for continuous. So the lead time of supply is simply 12 days. So my what is important here is why we are doing this particular calculation, or why we're trying to know this, is because I have to compute my minimum volume or maximum or safety stock based upon my continuous based upon the periodic review and the continuous review, right? For example, my calculation, suppose my average demand is 20 units, and for the min calculation for periodic review is 20 into 16, that is 320 units. This is for min for the periodic review. So I'm having 4 days extra, and I'm just trying to order 4 days additional inventory. So suppose my average demand is 20. For continuous review policy, my the amount of order I place supplier is 240 units. So order which I'm going to place supplier is for 240 units. In the case of continuous review policy, but in the case of periodic review policy, I'm going to order only I'm going to order for 16 period lead time. Okay, so this is the difference between the periodic review policy and continuous review policy. The only difference is that in the case of periodic review policy, if you are we need to have a leverage inventory or buffer inventory for the number of periods we are taking time to review the inventory metrics, because we are not going to look what is happening in the inventory. So we are just going to we are going to close our eyes, and then we are going to we are going to consider the 4 days as the buffer, and we're going to order additional inventory for those 4 days also. Right. So this is how we are going to this is how we have to understand what kind of inventory policy I'm actually bringing in the system. So we need to have that particular awareness. Are we going to review inventory every day? Are we going to review inventory after interval of after an interval of few days? So if we review inventory multiple times in a day or every day, then we call this as a continuous review policy. If we review our inventory of periodic intervals, then we call that as a periodic inventory policy. So we need to be very clear what kind of policy we are going to adopt, and if we adopt a periodic policy, then what is the interval? Those things, those decisions we have to make. And our model, our replenishment engine, which we have, right, which can work on both the ways, but our replenishment engine is best suitable for continuous review policy. So continuous review policy, and this gives a lot of control on inventory management. So our tool which we have developed, the replenishment engine which we have developed, it gives a lot of control on the on understanding the metrics and taking the making contingency plans and doing risk management, and so those things you get a lot of control with our tool. So because our tool is based upon continuous review policy, but if somebody wants to manage the periodic review policy, we can modify our template according to that. But we believe the time to process the insights is very only 5 minutes, right? Suppose if you are in a multiple, if you are in the morning time, you want to process your engine and wants to understand what is the inventory status right now, you just get everything in 5 minutes. Similarly, if you want to understand by the end of the day, right, it's only 5 minutes. So if you take less time to run your engine, it is better to use continuous review policy. Generally, periodic review policy is done when your time to process the information is very large. If the time to process the information and get the insight is very less, then why should not we switch towards the continuous review policy? That's the question, and that's what's the advantage we have. Now let's take the simple approach to calculation of our the order quantity and all. Let's see how to do that. For example, this is my reorder point, and this is called S, and this is called minimum. Okay, order up to level. This is called S, capital S, and this is called maximum. And what is maximum? Maximum is calculated using min plus safety stock. We have already done that calculation in the previous sheet. Min plus safety stock, right? So this maximum, which is called capital S, it is a sum of minimum plus safety stock. And this reorder point small s is called minimum. So what is the role of minimum? The role of minimum is the moment the current inventory or opening balance is either equal to reorder point or less than reorder point, we need to order the inventory, right? Or we need to order it. For example, let me draw a chart. So this is my x-axis, which is called a time horizon, and we are using continuous review policy. So we have no gaps over here. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, right? This is our continuous review policy. So we have time over here, and this is our quantity. So this is our S, small s, and this is capital S, right? Now let's say my current inventory at period number 3 is over here, right? At period number, let's take one more example. If my current inventory is at here, for period number 4 is over here. Okay, so let me draw a horizontal line. So if you look at this current inventory, it is more than the reorder point, small s. This current inventory is less than small s. So this is the place where we need to place an order. These are plant we may afford not to order. Right? So the initial inventory was here. Suppose this is maximum. We want our inventory should not cross this point. So we want our inventory up to this point. Right? So whenever we are falling short, so we need to take our inventory up to this point. So what is this point? How much is this point? This is current inventory. This is maximum. So this area is current inventory. This area is max, And how much we need to fill? This area. So this area is called max minus current inventory. This area is called max minus current inventory. This entire area is max, this area is current inventory, this area is max minus current inventory. Right? So this is what we need to order. So let's apply this technique in our computations here. So let's see what is my, I will try to address this in two parts. I'll say what is my opening inventory and closing inventory at each time period. This is a very most important thing. So what is the opening inventory? It is like 100 here, right? Let's say my opening inventory in the first case it is 100. So what is the closing balance? The closing balance is 100 minus demand. So this is what from the inventory we are going to consume 41 units. So the closing balance is 59 units. Now what we're going to do is we're going to check. What is the check? If my closing balance, if the closing balance is less than equal to my reorder point. If the closing balance is less than equal to reorder point, then I have to do the order. Or else not order. So if you look at here, we're saying not order because let me write the word not order. So because this 59 is a closing balance and this 59 is a closing balance more than the reorder point. We don't need to order. Right? Now we'll say how much to order, that also we'll write. Okay. This is a lot past of our discussion. So just have now whatever is the closing balance in the first week was the first is the opening balance for the second period. So this is my opening balance for second period. Now what I'm going to do, I'm going to calculate my closing balance. So 59 minus what is the consumption here? 21. So what is the inventory left? 38. Now we're going to drag this formula and check whether order or see. It is telling us to order because 38 is less than 50. 38 is less than 50, so thus this is going to be order. So how much to order? So how much to order? What is the max? Max is 100. And what is the current inventory? 38. How much to order? 62 units. 62 units. So this we're going to order and that will be considered as opening balance. So once we order, so that will be the opening balance for the next week, 62. Now again we do the same calculation. 90 units. 90 units means we have to order. Right? Now how much to order now? So now if you look at here, this is 100, we have 62 came here. Now we have demand, demand is how much? 43. 62 minus 43. So we order 62 and now 62 plus, okay, we order 62 and then the closing balance 30, this will be 62 is the order and closing balance is 38, Closing balance 38, it become 100, okay. So now after 100, we are left with 57, we don't need to order anything, right? So we don't need to order then, so what happens is this goes to here 57 and then we're going to calculate our closing balance, we get -6 and what we get here, we get the requirement to order, right? So how much we need to order here? So we need to order here this plus this. So this this minus this. Okay. So 106 units. What happens is this 6 units will be was a back order. This 6 was a back order. So this 6 units will go back here. So after fulfilling the back order, we are left with inventory of 100 units, right? Because this is going as a back order here. So this is going to as a back order. So after fulfilling the back order, we left with 100 units. So again, we are going to this opening balance, and we are going to the closing balance 51. So if you do the calculations here, no order, right? Again, this 51 is the opening balance here, and again we do the dragging here, and if you see how much, -6. So if you do order, and if I do the calculations here, so we're getting again 106. So this again 6 is the back order. We give 6 as here, again we left with 100 units here, right? So again, if I do the calculations, so I get how much, 2079. Order, not order, right? So now if you look at here, if I this is my 79, this is my closing opening inventory. Again I do the calculations here, 39. See what happens is I have to get the order now, right? So if I do the calculation again, so 100 minus 39, right, 61. So this 61 plus 39 is 100 now, right? 61 plus 39 is my 100. So again I do the calculation, 100 minus demand 52. Let me see the 48. Again I have to order. So what happens is I have to order how much, 100 minus 48. So this 52, 52 plus 48, how much? This 48 plus this 52. So this comes around 100 units here, right? So again I'm getting 100. Now I do the calculation once again. So this is 69. So no order. Okay, so my closing inventory is what, 69, right? So now if this is 69, so what I'm going to do, I'm going to subtract again 69 minus 41, right? This is 28. So I have to do the order. Okay, so what is that? Now I have to order how much? I have to order 100 minus 28, 72. So what is closing inventory now here? Closing inventory is 72 plus what I have, whatever is the closing balance, right? That's 100 units. Now again, this is 100 minus 63, 37. Again, we have to order. So what I'm going to order 100 minus, so 100 minus 37. So this is 63, and 63 plus 37 is order, and 37 is a closing inventory, right? That is 100 units again. So I'm going to again do the calculation. 56, not an order. So simply I'll take 56 over here. Okay. So again I do the calculation here. So if I do minus 12, so what happens is I'm going to order 100 minus 12. So this is 112. So this 12 will go as the back order. We left with 100 units here, right? So again we're going to do the calculation here. So this is counts 54, not order. Let me say this is 54 means my closing balance, and again I drag the formula here. So this is -7. So this -7 is back order, right? If -7 is back order, what I'm going to do again? I'm going to order 100 minus 7. So 7 is fulfilled, and my closing inventory or opening balance for the next is 100. So so we are doing, so what we are doing this calculation manually. So how to we need to consider the optimization. We need to consider the automation process for this, right? Similarly, if so, what I'm going to do is that if this is not odd, if this is equal to not order, then we have 0, or else we have 100 minus this. So I made a mistake in the grammar mistake. So this is order. See, if this is not order, we have 0 here, right? If this is not order, we have 0. Okay. Now let's say, let's automate the opening balance now. So we have to automate the opening balance. The opening balance is this minus we got 62. Okay. First of all, we have to, okay, this plus, let's say this plus 59. The closing balance is what we have. Okay, first of all, we need to take the closing balance 59. That's okay. And then we got 68, right? This plus this. Okay, so this plus if this plus 59, 38 plus 62. Okay, so now what I'm saying is that 38 plus 62. So this plus. So this plus this, right? So, so 100 minus 62. Closing balance from here. So this formula is automated now, right? This formula is now automated. What we have done is that if it is opening balance is initially 100, closing balance is opening balance minus demand, and then we are giving an check here, order or not an order. If it is not an order, it will be 0, right? So what is the what is the opening balance for the next period? The opening balance for next period is whatever the closing balance plus whatever we have to order. Closing balance plus order is the opening balance for the next week. Okay. Again, closing balance. Now we have to find closing balance. So opening balance minus demand. So I'll write the formulas here. So the closing balance is opening balance for the week minus demand for the week. Okay. And opening balance for next week is closing balance of previous week plus the order requisition from previous week, right? So this is a formula which we have used to compute our opening balance and closing balance. And the formula for calculating our order quantity is equal to opening balance minus sorry. So the opening balance, okay, yeah, the closing balance is, yeah. So the closing, let's say we have done the closing balance, yeah, opening closing balance is done. So order quantity is, we are doing calculation by maximum inventory minus the closing balance. Okay. So these are computations we are using to compute this, and we have automated this process. So now we go back to our previous sheet, and we're going to use, so this is a very simple thing I have taken. But if you have multiple transactions like in transit, POs, or cycle counts or leakages or expiries, so multiple transactions are there, then this formula will get more complicated. Okay, but this is how the calculation which we are doing over here. So guys, once again, I'll take back you to our engine, which we have talked about. So this is our complete engine, and there are n number of computations, thousands of computations, or millions of computations are happening in this engine, and it will only take 2 to 5 minutes of time to give you the automated output. And the cost of the product is very less as compared to the big company software product. If you buy any big company software product, it will cost you around 20,000 to 30,000 US dollars per year. But our product may cost you in between $3,000 to $5,000 for lifetime. And we are going to also give you 3 months life support. 3 months support. After it, we are going to offer our product in between, depending upon the data set, 3,000 to 5,000 US dollar. In this, we're going to offer 3 months support. We're going to provide training, free training on the tool, right? This is what, and we're going to complete knowledge transfer. Will complete knowledge transfer of the product to you. Okay, so the 3 month support is a very important thing, because you guys, your team has to know how to use the product, how to generate the outcomes, how to interpret the insights, and how to use the insights in the operations. So we are going to give the 3 month support in this particular time zone. So this is completely the general insights to operations support. Insights to operation support we are going to offer in the 3 months. It's a very low cost product, $3,000 to $5,000 or dollars in between that, depending upon data sites, and it is almost on 1/10 cost of the big company's product, but it is equivalent to any big company's products capability. So if you want to connect with me more on this, please email me at Krish Naidu at maternal.tech, or you can also WhatsApp me or +918121924637, right? So I can give you a demo also of the product. I can give you more information about. I can understand your requirements much better, and we can talk more about the product. So guys, I thank you very much for having your patience to to sit with me on this program. And if you have more questions, please feel free to connect with me. I'll be sharing more details on this. So meanwhile, I take my leave for today's program, and I thanks all the people who have attended this program. And and if you have any questions, I'm here for another 10 minutes. If you have any questions, you can ask in between. If you have any question, guys, please ask the questions, or if you can post the questions on the chat box or on the social media pages, you can post your queries also. Okay, so I think there's no questions from you guys. So thank you very much for attending the session, and I look forward to connect with you and share more details about our service offerings and the product offerings. So let's connect, and here's the opportunity to work with you and to improve your supply chain. Thank you very much, guys.